This is Algebra 2, Chapter 2, Section 4, in which we will be writing linear equations. Remember, we said linear equations are equations that graph out as lines. We're going to be writing equations based on information given to us in the problem. Okay. We already have seen that we can write a linear equation in standard form, ax plus by equals c. We're going to meet a couple of other forms in this video that will likely help us get to, not likely, they will help us get to standard form. Okay. The first one is called the slope-intercept form. And it's named that because in the graph, or in the equation, you get the slope and the intercept as part of the equation. The equation is in the form y equals mx plus b, where m represents slope and b represents the y-intercept. This is the form that most of you remember from Algebra 1, and it's the one you're the most comfortable with. Y equals mx plus b. M is slope, b is intercept. So let's write an equation in slope-intercept form through two given points, 0, -2, and -4, -1. Now to use slope-intercept form, we need to know the slope and we need to know the intercept. Well, we've got the y-intercept. That's right here when x equals 0. So now we need to find the slope. Well, like we did last time, the slope is y minus y, -1 minus -2, over -4 minus 0. Cleaning up the arithmetic, we get 1 over -4, or we could call that -1/4. So now we can plug the information into y equals mx plus b. Y equals -1/4 x, because that's the slope, and then plus -2, or you could just say -2, because that's the intercept. Okay. I'm going to ask you to pause here, try this problem out. Same idea, we're passing through 0, -6, and -4, 10. So again, first we had to find the slope. And we find the slope is -4, so we plug into the equation y equals mx plus b. Y equals -4x minus 6, because that's the intercept. That's where x equals 0. Okay. I'm not just randomly in either of those two problems picking a point to use the y from. I'm choosing it purposely because x equals 0. Now that's all well and good if we know where the y-intercept is. If we don't know the y-intercept, we need a new plan. And we have a couple of options. We have a couple of different ways we can go. The one I prefer is called the point-slope form of the equation. And the name tells you exactly what you need. You need a point and you need a slope. The point-slope form of the equation looks like this. Y minus y1 equals m, the slope, times x minus x1, where m represents the slope again, and x1, y1 is any point that is on the line. Notice the distinction here. I don't need the y-intercept like I did in the other form. Here, any point will do. So let's write the slope-intercept form for an equation of a line that's passing through 6, -2, and we know a slope is -4. Now they want us to get to slope-intercept form, but we don't have the intercept, so we're going to have to do a little bit of work here. We're going to start with point slope, because I have a point, 6, -2, and I have a slope, -4. So I'm going to plug that information in. Y minus the y number equals the slope times x minus the x number. Well, from here it's easy. We just have to distribute. I'm going to clean this minus -2 up into a +2. You can go straight to that step if you want to. I just wrote it this way to illustrate it. Distribute the -4. So we get -4x and +24. Now if we want to get y by itself, all we have to do is subtract the 2 over. And we get y equals -4x plus 22. Let's do another one where we don't even have the slope. All they've given me in this problem, all they've given us, is 2 points. And they want the slope-intercept form for the line. Well, the best way to go after this is to first work off of point slope, which means you need a point. We've got 2 of those, and we need a slope. So let's find the slope. Well, using the slope formula, y2 minus y1 over x2 minus x1, a little arithmetic leads us to the slope is -2. Now I've got a slope, and I can pick either point I want to. It doesn't matter which one, because I'm going to plug that in to point slope form. Y minus y1 equals m x minus x1. I chose the second point. No special reason, I just did. So y minus -3 equals -2 times x minus 3. The -2 here is the slope. It's not the -2 from the other point. It's the slope. Well, let's do a little cleanup work. Y plus 3 equals -2x plus 6. Subtract the 3 over and we get our equation, y equals -2x plus 3. So I'm going to ask you to pause here and give this one a try. It's the same idea. I'm giving you 2 points, 4, -9, and 2, -4, and asking you to find slope-intercept form from there. So pause here, solve the problem, come back, check your result. Well, just like before, we needed to find a slope. Plugging into the slope formula, we get -5/2 for the slope. Again, I picked the second point to use, no special reason, just because. I mean, there's no rhyme or reason to it, it's just the one that I used. So y minus -4 equals -5/2 x minus 2. Do a little cleanup work and we end up with an equation, hopefully, of -5/2 x plus 1 equals y. Now there's a couple of special cases of lines that we need to talk about here. One is called the parallel lines. You know them as lines that don't ever intersect, they never meet, kind of like the lines on your notebook paper. Well, when they're parallel lines, they have the same slopes. Parallel lines have the same slopes because they move the same direction. The other case of lines is called perpendicular lines. Now you probably remember that perpendicular lines meet at right angles. Well, when we talk about their slopes, they are opposite reciprocals of each other, and we'll talk about what that means in a couple of minutes here, over on the next slide. But they're going to ask us to write equations of lines through this, in this case 5, -6, and they want us to write it parallel to this equation, y equals -3/2 x plus 7. Well, parallel tips me off to something. Parallel lines have the same slopes. So I need the slope of this line. The slope of this line is a -3/2. And I've got a point, 5, -6. I can plug those two in. Y minus -6 equals -3/2 x minus 5. Cleaning up, y plus 6 equals -3/2 x plus 7.5. Subtract the 6 over, and we get our final equation, -3/2 x plus 1.5. You could have 3 halves here. It would be the same thing, or 1.5, any of the above. But the key was we had to recognize that since the lines are parallel, they have the same slope. So the slope of this line is the same as the slope of my new line. Now let's consider the same idea, but let's go perpendicular to it. Okay. We said perpendicular means that the slopes are opposite reciprocals. The slope of this line is -3/2. And we want the opposite reciprocal. Well, that's going to make that positive, because opposite of negative is positive. And then the reciprocal of 3/2 is 2/3. So my slope is 2/3, and my point is 5, -6. Plugging that information in, y minus -6 equals 2/3 x minus 5. Do a little distributing, and then subtract the 6 over to get to our final result of 2/3 x minus 2 2/3 equals y. We could say 2/3 x minus 8/3 if you wanted to. So we went through quite a few things here. We went through slope-intercept form, y equals mx plus b. We went through point-slope form, y minus y1 equals m times x minus x1. We talked about parallel lines have the same slope, and we talked about perpendicular lines have slopes that are negative reciprocals. And as always, hopefully if you had questions along the way, you wrote those down, bring them in with you, and we will see you in class.